Now there is a slight challenge in front of us. Over here we find that a boy is rotating a stone by tying it with a string. So what he has done is he has taken the stone, tied a string and held the string at the other end and is rotating it. But there is a challenge which he faces. That challenge is that he is unable to rotate it with a uniform velocity. He finds that no matter how hard he tries, he just cannot rotate it with uniform velocity. Now he places the challenge in front of you. Can you rotate the stone with uniform velocity? Well, let us find out. Well, the answer is a strict no, because it is impossible to rotate the stone with uniform velocity. You can tie the string to the stone and rotate it as much as you like in whichever way you like. But you will find that at the end of the day, it is impossible to rotate the stone with a uniform velocity. Why? Let us consider different positions of the stone while it is rotating. So first we have considered this particular position at the top. Now over here, as the stone is rotating in this manner, you can see that the direction of motion is towards west. Now over here, the direction of stone is towards the west. What happens in a different position? When this stone rotates and all the way it comes down to this particular point, we find that the direction of the stone or the direction of motion is towards south. Similarly, once it rotates all the way from here and comes to this point, over here we find that the direction of the stone is towards the east. And even further, we find that when the stone moves from here all the way to this point, the stone is pointing towards north. And then again, the entire cycle will be repeated. So we find that at every point, the stone is changing direction. That is to say, when a stone is rotating, the direction of the stone is changing at every instant. And what do we know about velocity? We know that velocity is a vector quantity and it has a certain direction attached to it. So we can say that whenever there is a change in direction, there is a change in velocity. Because as I told you, velocity is a vector quantity and it has an associated direction. So direction and velocity go hand in hand. Now when there is a change in direction, it implies that there is a change in velocity. So this means that when a stone rotates, the velocity is constantly changing and it can never be uniform. Because as we found out from the previous example, the direction of motion of the stone at different points was different. So this is why the velocity can never be uniform. Now let us talk about a different scenario, a slightly different scenario. Over here again we consider the same stone rotating in a circular path. So first we consider the stone at point A. Now if you take a stopwatch and you measure the time, let's say for stone A, for stone to reach from position A to position B. And let's say that the stone takes 0.1 seconds. That is, in covering distance AB, the stone takes 0.1 seconds. You will be surprised to know that the stone takes the same amount of time to cover position B to C. Similarly, if the stone has to cover C to D, it will take the same time. And lastly, from D to A, again it will take the same time as it did from A to B. So we see clearly over here that time taken to cover distance AB, BC, CD and DA remains constant, equal to 0.1 seconds. So what can we conclude from this? We can conclude that since the stone is moving equal distances in equal periods of time, the stone is rotating with uniform speed. So even though we have seen that the velocity is not constant or not uniform because there is a constant change in direction, the speed is uniform because it is covering equal distance in equal time periods. In this case, 0.1 seconds. So such kind of circular motion or rotatory motion is known as uniform circular motion. So what is special about uniform circular motion? When an object moves in a circular path with uniform speed, its motion is called uniform circular motion. Now over here, there are two key points to remember. What are those two key points? The first point is the object should be moving in a circular path. And the second key point is it should be moving with a uniform speed. Only when the object satisfies these two criteria can we say it is executing uniform circular motion.